Hello and welcome to the first tutorial. In this tutorial, I will be talking about a ctree function that is available in the package party. I will be showing you the decision tree algorithm using the ctree function and using the iris dataset. So what basically decision tree is, decision tree algorithms give you a classification or regression model in a tree-like structure. And what it does, it takes the data set and divides it into subsets and classifies them or makes a regression model in a tree-like structure. So this is a code. So let's execute this code. So first we are taking the iris dataset, that is st as iris. You can see that there are 5 attributes that are present in this dataset, that is the sepal length, sepal width, petal width, and the species. The species is the supervised attribute which will be supervising this dataset. Decision tree algorithm, by the way, is a supervised learning algorithm. What it basically means is it already has a class label defined, and according to that class label, it takes the new training and test dataset and performs classification on them. So now we will be setting seed to this dataset. Uh, and in this following step, we are taking the probability of 0.4 and 0.3. That is, the training data will be 0.7% of the entire data set, and 0.3% will be the test data set. And we are storing this into an int variable. So let's execute this. Now we are telling that the training dataset will consist of iris from indexes 1 till the rest, and test data will consist of iris dataset within 2. That is, train dataset will have all 0.7% of the observations present in the dataset, and test data will have the remaining, like that is 0.3% of the dataset. So let's execute both of them. Now we install the package party. Okay, there's an error that has been thrown. So we will go to packages, we'll find party here, and we will just tick box that party, just tick it. So the package is now available to us. Now what we are going to do is we are going to form one variable in which all these attributes are like collaborated, concatenated, and put. So for us, that variable will be my formula, and the rest of them are, as you can see, sepal length plus sepal width plus petal length plus petal width. Species is written in the first because this is the one which will be supervising the entire like classification algorithm for iris dataset. That is why. So we go here, no errors. Now we perform the ctree function, which takes two parameters. First is the entire the variable that we formed in the previous step, and the training data set that you want to provide. So we are storing that in iris ctree variable over here, as you can see. So let's execute this, and we'll find the table of this iris ctree with the training data set species, because species is the attribute which is supervising or is acting as the supervising attribute. So here we can see is uh, that there are 39 classification under setosa, there is 36 correct classification under versicolor, and there is 33 correct observations under virginica. But there is one wrong classification under virginica which is classified as versicolor, and 3 in versicolor which is classified as virginica. So let's print this C tree and we'll plot it as well, so that let's zoom on it. Now I will be explaining this plot according to the ctree print ctree function that we statement that we executed. So here what we have is, if the petal length is less than equal to 1.9, it falls under this category. In this category, we have 39 nodes in which all are correctly classified as setosa. Now, if petal length is less than 1.6 and if petal length is greater than 1.6, here we get this classification. And if the petal length is less than 1.9 and petal length is greater than 1.9, we get this classification, this branches. So, sorry. So now we'll see petal width less than 1.6, the criteria 1. There is another criteria 1 and there is criteria 0, 2. So in this we have the petal length less than 4.6 and in this we have petal length greater than 4.6. In petal length less than 4.6 we have all 30 nodes classified as versicular correctly. In greater than 4.6 we have, out of 9 nodes, we have 6 nodes that are classified as versicular and 3 nodes which are classified as virginica. And when the petal width is greater than 1.6, then we have 34 nodes in which one is wrongly classified as versicular, rest all are classified correctly under virginica. And you can see it in the table itself that I'm so sorry, that there are 39 which are correctly classified as setosa. So all 39 correctly classified as setosa which have petal length less than 1.5. Versicular has two variation, that is petal length less than 4.6 and petal length greater than 4.6, in which there is 30 plus 9 nodes in total there should be. So we have 36 plus 3, that is 39. So this is correct, like all are classified over here. For virginica, we have 33 plus 1, that is 34. Over here, we have 34. So you can see. So this was what the plot was. Now we will plot a simple C tree. That is the same thing, but instead of the graph, uh, bar graph, we get this matrix form, parametric form equations where we are telling that all are classified as setosa out of the 39 nodes, and 0 under versicular and 0 under virginica. Similarly here we had all classified under versicular, so we have y0 comma 1 comma 0, that is 0 under setosa, 1 under versicular and 0 under virginica. Similarly here we have, out of 34 nodes, we have 0.029% classified as versicular and 0.971 classified as virginica. Let's see the test predict variable. So we are taking this iris C tree variable that we had formed, in which the C tree's value is stored, and we are testing it with the test data, and that we are using the function predict and saving it into the test spread variable. And now we'll see the test spread um, table with the test data set learning that this algorithm had done. So over here now we have setosa, 11 of them are correctly classified under setosa, 12 are correctly classified under versicular with one wrong virginica classification, and in virginica we have one versicular wrong classification and 13 correct classification. I hope you understood this. That's all. Thank you.